Hello, everybody. Yeah, this is our eighth session, and this episode is going to be focusing on two drones. So, in my previous sessions, we had discussed about product development, the different processes involved in the product development, and how the digital engineering part is going to substantially influence on the product development aspects. So as we discussed, uh, we primarily saw what is a product, how it starts, from where the concept originates, and how the concept is put on the paper, how the stylings are done, and how the engineering portion is taken care of, how the geometrical tolerances and dimensioning aspect influence this, and how does it become a meaningful engineering structure. And we also saw the prototyping part. We also saw the validation part, the design validation part of it. We also discussed about the design for manufacturing capabilities, and then we fixed a process for that, and based on that process, several simulations were done, and based on those simulation results, the product was finalized. The best, the optimal, and the most efficient product was arrived at, and then the processes involved in manufacturing was also dealt with, and then the process for production was also focused on. So today we are going to discuss one such product, an aerospace product, okay, which is widely used in almost every applications today. So as I told you, a drone is unmanned aerial vehicle or an aircraft without a human influence or a pilot on board. They can be controlled remotely or they can fly autonomously. So remotely, like we have a controller, we have a certain set of hardwares, we also have sensors, and we try to uh, create a system where this particular system will be able to control or regulate the aircraft. So that is, we can fly this particular unmanned aerial vehicle through two ways. One is remotely controlled, and the other one is autonomous, where we have the certain set of hardwares, certain set of sensors, and a set of coding, a software that will be able to take care of the system, and automatically, autonomously, the flight will be able to move through. Okay, so they have navigational systems, they have GPS, they have sensors, they have computer vision, and they also have a set of programming. That's what we call as coding. So generally, it's like a machine learning system. So we make use of tools like Python, R, Keras, TensorFlow. So these are all the tools through which we autonomously regulate or control the flight. So now, sorry, let's see where exactly this is adopted. So initially, the drones were specifically designed and developed for the military applications, homeland security purposes, etc. And now it is more widely used in the civilian purpose also, especially for commercial applications like photography, surveillance, delivery, healthcare, agriculture, firefighting, etc. So now let's get into the detailed, you know, aspect of the drone systems. So a drone is an unmanned aircraft, meaning it doesn't require a pilot or there is no need for a pilot physically present on board. This is completely a very small, system and weightless system, which will be either about 100 kgs or 200 kgs or even lesser than that, say about 40 kgs, 50 kgs, etc. The total payload, and this will be completely operated through your remote control. Okay, so which means that that will include a lot of electronics. Now there is a specific technology with which flight takes. I mean, the flight flight is taken care of. So drones are equipped with various technologies, including GPS systems, cameras, radars, lidars, and other sensors for navigation and data collection. So mainly, these drones were used in the military or the homeland security for collecting data. So get into the enemy territory, try to understand the topography of the territory, and try to identify uh, if there are any enemy constructions or any kind of enemy interventions or including enemies are trying to cross the borders, and also to find out if there are any illegal kind of activities being set up by the enemy territory. Okay, so these are all the main important activities that was supposed to be monitored or that is supposed to be monitored. Okay, that is called surveillance. Now they have wide applications, as I told you in the military applications itself. They have reconnaissance, surveillance, and even targeted attacks. So reconnaissance is nothing but moving from one point to the targeted location and complete the mission and then return back to the base. So this is called reconnaissance. So most of the aircrafts, uh, piloted aircrafts, are generally reconnaissance based. They go to the specific target, they attack the target, and they come back to the base. Okay, so now, there are uh, systems, the missile systems, or there are even rockets that is today reconnaissance based. So it can go to the target location and it can release the warhead. Okay, it can explode and wipe out the entire target, and then it can come back. So different possibilities and combinations are there based on the requirements and the necessities. So now we have commercial drones, which is usually adapted for photography purpose, videography purpose, packaging, delivery, etc., etc. Now they are categorized based on the size. So the smallest, drones called nano drones, which are generally used for surveillance purposes. So they even they look like grasshoppers or butterflies or very miniature creatures, and this is sent into the enemy territory, and probably this cannot be hunted down, or it cannot be traced under radars. Okay, so now they have small flight durations, probably about 30 minutes to 45 minutes. They go across the enemy territory, try to get all kinds of possible photographies, high resolution images, and based on these images, there are some enhancements also done at the base, and similarly they also pass on very crucial informations. uh, they can get the informations about underground bunkers, or they can also monitor continuously. They can also monitor the activities happening, etc., etc. Okay. Now we also use it for civilian purposes. So that is for firefighting, transporting food items, transporting medicinal items, and for rescue purposes also. So some situations, very crucial situations where there are natural calamities or disasters, and many amount of lives are at toss, and the regions are totally cut off from the mainland, and it becomes very difficult for people to transport immediate rescue elements like medicines, survival kits, etc. So all these activities can be taken care of with these aerodynamic structures or unmanned aircraft, aerial vehicles, uh, and that can be successfully, taken out, carried out. So they are nano, and there are miniature or micro drones, and then there are slightly macro drones, and then comes the unmanned aerial vehicles. So it is again categorized based on the weights. So from 10 grams, say, to about 60 grams or 75 grams, we have a categorization. The drones are categorized into nano drones. And then from 75 grams, or say from 100 grams to say probably about 1 kg or 2 kg, we also have a categorization. And from 2.5 kgs up to 10 kgs, we have a categorization. And from 10 kgs to say about 25, 30 kgs, we have a categorization. So likewise, these drones are all categorized based on the weights. And there are some very important regulatories also following this. So the tiniest drones, the micro drones, the nano drones and micro drones up to a certain weight, there is no need for any certifications or strict regulatories, etc. That can be flown. Flew anyway. Whereas those drones, that are a bit higher, larger in volumetric, like the containment, etc., and the bulkiness, etc., and also based on the complexity of the applications. Okay, these drones are to be certified by civil aviation sector. So here in India, we have a Directorate General for Civil Aviation (DGCA), who is supposed to be allotting the certification, and only based on the certification, the manufacturer will be able to manufacture these drones and use it for commercial purposes, or even for the military applications. Now, let's see what are all the advantages of using drones. Now, the biggest benefit, there are numerous advantages, and out of which the biggest benefit or advantage is the safety part. Okay, so they can perform a very dangerous task, involving very complex processes, and it can also gain access into those environments which are generally complex. Say, for example, highly radioactive areas, environment, or high temperature environments, or those environments where you have all kinds of very dangerous species, say venomous, elements, or animals or birds, or whatever it is. So let's say like a deep forest where you have all kinds of poisonous snakes, and human intervention becomes very possible, and they need to understand the topography, and they need to understand the species. So in such cases, drones will make the biggest advantage. They'll be the biggest substitute for instead of human beings, and they are very efficient also. So drones can cover a large area very quickly. Say, today, the agricultural drones designed and developed by us uh, can fly almost about 40 minutes or 45 minutes. Almost about 60 to 70% of the total endurance, and cover almost about 5 acres of agricultural land. So 5 acres at some point of time used to be a huge area, and watering. the area or and fertilizing these area, spraying pesticides or fertilizers used to be a highly challenging task, okay, which involved a lot of human labor, cost, time, and the rate of process used to be very less. And then, there used to be a lot of other issues that probably could, prove it to be overall totally a costly affair. Okay, so today we have technology with which we can absolutely avoid all those, and we can work out the complete commercials in a very cheaper manner, and this does not involve huge labors. So we just need the pilot, and we also need the drone, and then we just need accessories which is connected to the drone. That's all. So, uh, those areas where a huge amount of labor is involved, this particular drone will be able to do the task. Now, as I told you, it's again a very cost-effective manner. So, comparing the cost of a tiller or a tractor or any other agricultural equipment, or comparing it with a helicopter, because earlier choppers used to be hired for spraying pesticides and fertilizers. Okay, so today, uh, by the technology enhancement and innovation factors, okay, we have arrived at these kind of unmanned aerial systems, which probably has reduced huge costs. Okay, so now let's see how these drones work. So as we know that any aerodynamic system needs a particular lift and a drag, and based on the pressure difference, the object gets lifted into the atmosphere. So this is the basic aerodynamic concept. Now for drones, it's again the same. They the drones generate lift and thrust using propellers or wings powered by motors. So there are two types of unmanned aerial vehicles. So one is drones, and this particular drone will be propeller driven, and it can be either uh, a quadcopter with four propellers. It can be hexacopters. It can be an octocopter, etc. And the same drone, we can categorize it into a miniature aircraft system where it has a wing, it has got a tail end, and it also has a nose cone. It functions similar to the aircraft, but it makes use of the wings and the radar systems. So here, uh, these propellers or wings are generally powered by motors, and these motors are driven by batteries. So today we have drone systems that can operate in power. So that is your battery power, and there are drones that can be operated out of fuel also. Okay, but it again depends on the regions or the area, the sector that we are trying to operate. Okay, so as you know that today, I mean, sorry, these days we have a lot of war going on between countries like Ukraine, Russia. We also had a war between India and Pakistan, and similarly, war between Israel and Iran, Israel and Palestine. So all these wars today uh, are very high-tech war. See, why I call it as high-tech is most of the systems adopted for this particular war are all very, highly technology bound. So we have all kinds of drones which is being utilized, autonomous drones, semi-autonomous drones, and then they also have, aircrafts, okay, hypersonic aircrafts. They also make use of missile systems, anti-missile systems. So likewise, it's basically an industrial revolution Okay, and people, all countries are trying to, like prove, like we are bigger, we have all kinds of technologies. It's something like that. Okay, and we see that a lot of countries are good and far efficient enough, and they have all kinds of weapon systems, weapons for mass destruction, etc. Okay, so like this particular era is a technology era. So this is Industrial Revolution 5, 6 going on. So let's again come back. We also need a flight controller. Flight controller is basically it's the brain of the particular drone. So I'll just give you a small example. Uh, there used to be a time when we were making use of Pentium 2 processor, Pentium 3 processor, AMD processors. So those were the time, like people were under the impression those were the biggest technologies available, Pentium 3 inside and P3 processor, very high speed, etc. But today we have blade servers, and we also have GPUs. Okay, and the uh, memory capacities are in fact in terms of terabytes. So those days it used to be about like 2 GB, 10 GB, 50 GB, etc. So today we have the hard disk capacity itself about 1 terabyte plus. So we know that over a period of time, there is definitely a change in technology because of industrial revolutions. Many countries put good amount of money into research and development, trying to come out with extremely powerful machines, etc. Okay, so we have systems like drones now, uh, which is semi-automated and fully autonomous also. So they make use of flight controllers, and these flight controllers are the brain. So they process data from sensors like gyroscopes, accelerometers, magnetometers, uh, etc. for stability and direction. So, as you know that any levitating structure or any flying structure needs to stabilize its position, path, etc. Now, uh, when there is a pilot inside the vehicle, the air vehicle, the pilot does the maneuvering, and whatever the pilot does inside, the entire system adheres to that. So let's imagine a situation where we don't have a pilot and everything is remotely operated. So there should be a synchronization between the pilot outside operating the remote and the vehicle, the air vehicle moving at a altitude. Now this is possible by means of GPS, and this is also possible, made possible by means of Wi-Fi, etc. So we have a transmitter system, and this transmitter takes care of all the actions that is performed on the ground. So we also have ESCs, or called electronic speed controllers or stabilizers, and these regulate the motor speed and direction. Say exactly in case of the helicopters, where the chopper pilot is inside of the cockpit and then he maneuvers the helicopter. So he is the one who takes control of the uh, propeller on the top, and also the propeller, I mean the wing. Okay, so there are two propellers. One is for lifting, and the other one is to guide. So the tail and rotor is something that guides. So the pilot or the chopper pilot is able to simultaneously drive both the mechanisms. So here, in case of the drone, all these things are performed by the pilot who is outside. He is on the ground. He or she is on the ground, and the unmanned, the aerial vehicle is on the flight condition. So all these, uh, maneuverings, or all these actions, what the uh, pilot does here outside the aircraft has to be reflected in the aircraft. Okay, so they make use of the sensors, and these sensors are again driven by some commands. Okay, and these commands are nothing but the logics or the codes, based on which they they are able to control or regulate the vehicle. Now batteries are those components, they power the systems in the drone. So what are all the systems? We have the controller, then we have the motors, and we also have all the other sensors, okay, on the drone systems. There will be a pressure sensor, a temperature sensor, okay, moisture sensor, and also sensors related to other activities. And they also have radar systems, they have a GPS system, they have a lidar systems. Okay, and all for some purposes. Okay, and I'm not trying to make it complex. I'm trying to make it as simple as possible here, so that the beginners will be able to understand. They'll be able to visualize like what are all the entities and how it can be synchronized or it can be connected with the hardware systems and the sensor systems. Now, the remote control systems usually operate via radio waves like Wi-Fi and allow the operator to send commands to the drone. Okay, so the controller needs to, I mean, the remote pilot or the pilot needs to, control the drone, have to say the drone that you need to now glide towards the right, and then focus on those regions which is completely dry. The land is completely dry. Let's say that it's a agricultural drone. It's a fully autonomous agricultural drone enabled by AI. And the drone has got a GPS, it has got a gyroscope, it has got magnetometer, it has got accelerometers, it has got all kinds of sensors. It also has a radar system, it also has a lidar system. Everything. It's a full-fledged agricultural drone. Okay, so there is a flight controller inside the drone, and then there is a remote uh, mechanism outside, and the pilot has taken charge, and he has initiated this particular drone, and the drone now is moving steadily. And the drone, being a fully autonomous system, it has decided, it has understood the topography, it has mapped the complete region, and based on the region and with the kind of sensors that is it is mounted with, it is trying to visualize like which are all the area which is greener, which areas are all brown, which areas are completely unfertile, and which area has got a lot of fungal attacks or pest attacks, and which region needs to be put a lot of focus, and what should be the minimum moisture ratio, and what is the present bearing capacity of the soil there, and what is the present moisture ratio. So everything is decided by the fully loaded or a fully enhanced agricultural drone. And the drone starts, okay, from a specific region, and based on which it automatically controls the field, that is uh, the pressure chamber from where the water or pesticides or the fertilizers are being sprayed. The mechanical systems, including the nozzles, they become alert, and the quantity of discharge of water or pesticides are all completely programmed, and based on which this spraying takes place. Okay, and now we also understand that this is a structure very similar to an aircraft. So, in an aircraft or a helicopter, where huge gallons of fuel is contained within the tank, and this particular structure, the aerial vehicle at motion, there is a lot of dynamics which is involved in the structure, and because of the dynamics, it is not only the structural movements, and because of the air resistances and turbulences or any other mm, mechanical forces, okay, there will be a counter force exerted on the structure due to other non-solid or non-structural elements. Say, for example, fuel tank has got a fuel. The fuel will be able to. Fuel is generally, sloshing. It keeps moving from one area to the other, and because of two or more layers of fuel uh, in when mixed with the air, okay, there is a probability for it to catch fire also, and that will prove very fatal. And now, very complex simulations have to be performed on these structures even before they are subjected to dynamics. So similarly, there will be a lot of sloshing in the tank. The pesticides or water or fertilizers are filled. And let us take a typical 10-liter agricultural drone, where there is a total volume capacity of 10 liters, and the tank is contained with fertilizer. Okay, and during the flight there is a enormous amount of inertia, and because of that inertia there is a backlash of fertilizer, and then there is going to be a completely different dynamics on to the structure. Apart from the regular dynamics, there is going to be a huge fluid dynamics also induced on the structure. So all these systems have to be monitored, and we have all kinds of sensors available on the system or installed on the system. Okay, and now whatever actuals are happening, the complete real-time picturization is brought into the system. Okay, so this is a typical way of correlating the actual system with the real-time system. Okay, so we have a virtual parameter, we have an actual parameter. The virtual parameter and the actual parameters are compared, and based on this comparison, one parameter can be adjusted with the other, or it can be correlated and updated with the other. Okay, so now drones are classified into various ways. Okay, including by their design aspects, or their capability aspects, or the application aspects. So some common classifications are fixed wing drones. They resemble exactly like an airplane with a wing and tail end, etc. And they are energy efficient and ideal for long range missions. Say almost about 10 kilometers or 15 kilometers have to be completely traversed, and 10 to 15 kilometers it's a long span, and long span, there should be a good amount of aerodynamics also coming into picture. Say, for example, on the lower atmosphere, where the typical drones fly, say about 600 meters, let's say 300 meters to 600 meters, an agricultural drone flies. Okay, and there's a huge weight, and this weight is being compensated, or it's being taken care by the motors, I mean the propellers. It can be a hexacopter or it could be an octocopter, depending upon the weight. And what happens is, because of the weight, there is a good amount of work done, and this work done will be able to lapse the power, whatever power we are supplying to the drone, that power will be lapsed in a very short span. So that's the reason these kind of drones are not capable of flying more than 40 minutes or 15 minutes continuously. Okay, so every 30 minutes or 35 minutes, the drone gets a uh, you know an indication, or they get a alert from the system, and based on that alert, it will try to come back. If it is fully autonomous, it will calculate automatically like what is the total distance and what is the power capacity. Based on that power capacity, it will go to the destination and come back. So at some case, if it feels like the battery is draining out because of some other parameters, and it is not possible to reach the destination, what it does is it will either uh, try to break that particular journey there, or the mission there, and then it will come back to the base station. Okay, so now we have multi-rotor drones, and these multi-rotor drones are what we are talking about, the quadcopters, with four propellers, hexacopters, and octacopters, etc. And these number of motors are increased based on the load carrying capacity. Say, for example, if the drone is not having a big payload, and the payload is very less, then the entire system can go with four motors and four propellers. So that is quadcopter. But sometimes when the total payload increases, the mass increases. Okay, and accordingly the density also changes, and then there will be a lot of dead load. Okay, so now in order to accumulate all these dead load, contain all these dead load, okay, we try to improve, the structure. So from quadcopter, that is from four propellers, we increase it by six, or say by eight, etc. Then we have hybrid, eVTOLs, electric VTOLs or hybrid VTOLs. These are also drones actually, and these combine the advantages of both, uh, the eVTOLs, that is your fixed wing rotor system, as well as the the what do you call, the multi-rotor system. Okay, so the fixed wing drones, you have an aircraft like structure with wings and tail end and the rotors. And in addition to this, let's imagine that it also has got the multi-rotor drone design also. Okay, so these two combined together becomes the hybrid VTOLs, and these hybrid VTOLs are generally used to transport, people from one place to the other. So it is similar to your two what do you call, two-seated electric vehicle which is moving on the roads. Okay, so similarly a two-seater system which is flying in the atmosphere. Okay, so that is that you can visualize it. I mean, the hybrid we told you can visualize it in that way. Now let's try to understand like where all these can be utilized. So we discussed about agriculture. We also discussed about military applications. Now we also discussed about an area where natural calamity has occurred and people have to be transported, or there needs to be medicines transported, and food packets and things to be delivered to the people in the affected regions. So for all those purposes, we can make use of these drones, and they are also extremely used for environmental monitoring purposes. So as I told you, already these systems they contain sensors, pressure, temperature, whatnot. All kinds of sensors are there, and now making use of these sensors, they are made use for retrieving data or for getting data from the atmosphere. So they take care of the climatic conditions. They study the studying the monitoring the deforestation, etc. Tracking wildlife people. I mean wildlife and other people. Strangers getting into what do you call, unsolicited areas, or trespassing, trespassing of people in unsolicited areas. All these things can be monitored, and we can also use it for mapping purposes, surveying and mapping purposes. Say today, nowadays, it is quite common. Like the Gram Panchayat has also, enhanced the surveying methods, the primitive surveying methods with a theodolite and a chain surveyor, and people, they take about 2, 3, 4 days, or up to a week for the complete surveying process. So all those things are enhanced today with the technology, with the application of drones that is generally used for surveying and videography and photography, etc. So the complexity of the system becomes very simple, and it is very simple for the surveyor to construct 3D models and of the entire area. Okay, so the approximations are reduced and the accuracies are increased. Now, what are all the future? capabilities of the drone. So now the drones are continuously evolving. Every day there is some kind of advancements happening. People are trying to incorporate a lot of functions into that. Okay, and today we know that we have 5G capabilities, and we also have a very advanced computation technologies. And so, based on those advanced computational technologies, the abilities, the capabilities are also increased. Okay, so now we have, as I told you earlier, we have very high speed computation facilities, GPUs, etc. And simulations can also be performed using very high speed data and using these GPUs. Okay, so every day, there is an enhancement, I mean, the advancement in technology, and based on that, the system can be, what do you call, the drone systems, whichever drone systems we are using, that can also be enhanced. Okay, so we are also looking at the possibility of urban air mobilities. Okay, so transporting people from one place to the other place in a very short span of time. Okay, and without the influence or without the intervention of any other structures like aircraft, depending on any other systems like aircrafts, etc. Because those are all very costly affairs. So to make the mobility, the air mobility easier today, there are a lot of enhancements done to the technology. So today we have discussed about drone. We have understood what exactly drone is, what are the different applications of drones, and what are the benefits of using drones, and what are all the elements inside a drone, and how these drones are helping or supporting today's system in a bigger way, and how it is complementing people from every industrial segment. So all these things we have seen, and I also, request you to kindly get onto the website, our website, and you can also find the kind of drones that we are developing, and you can also find the technology that we make use of, and you can, you should, you can probably, find many other informations from the Google again. But what I'm trying to do here is, the entire system. I have converged it and I have put it in a 30-minute or 40-minute presentation. And I think I have put everything in a very simplified manner so that, a common man can also understand and visualize what exactly these drone systems are and how it is operated and what are all the benefits and etc. Okay, so let me request you once again to subscribe this particular channel. Okay, the very reason being all these videos are connected to one another. Okay, and if you miss one video, you will not be able to get that particular link. Okay, so I advise and I suggest that everybody subscribe this particular channel, and you can also find a link to the website. You can go through the website, and you can also find a lot of information regarding the details that I gave you today. And please feel free to put your own suggestions and comments, and always ensure that you share this particular thing to other people also. So kindly subscribe and share the thing, and feel free to comment. Okay, you can feel free to send me your own queries, and definitely that will be taken care of, and I will try to give you or get you, the most appropriate information that you are looking for. Okay, so thank you very much for this particular episode. Okay.